Okay, so the next part of vectors at higher level is unit vectors, and we're going to look at them in more detail. So a unit vector is any vector which has a length of 1 unit. So if you remember back to the last video, there were 3 important unit vectors, which were I, j, and k, and those were the 3 vectors, each of length 1 unit, in the direction of the x, y, and z axes respectively. So if you remember that I was a vector in j was 0 and k was 0, 0, 1. So for any given vector, we can identify a unit vector that points in the same direction, so in other words, it's parallel, by dividing its components by its magnitude. So if we look at this example, we're going to find the unit vector u that's parallel to vector v, which is 3i plus 2j minus k. So the first thing we want to do is we want to write down vector v in its component form. So vector v equals 3, 2, negative 1. And then we want to calculate the magnitude. So the magnitude of v is going to be 3 squared plus 2 squared plus negative 1 squared. And we're going to square root that. And we're going to leave it in surd format. So our answer is root 14. Now, the next thing we need to do is find that unit vector, and as it says above, we're going to divide each of the components by the magnitude. And that's because, if we think about it, we have 14 times the unit vector is equal to our vector v. So if we divide both sides by root 14, then we're going to end up with vector u on its own. So we can write that in 2 different ways. We can write vector u equals, and we can just multiply by the reciprocal and put vector v in a bracket. So it's 1 over root 14 of the vector 3, 2, negative 1. Or we can actually divide each of the components by root 14 and write it as 3 over root 14, 2 over root 14, and negative 1 over root 14. So that's our unit vector. So a unit vector is parallel, but its magnitude is only 1 unit long. And if we were to then work out the magnitude of u, if we do 3 over root 14 squared plus 2 over root 14 squared plus negative 1 over root 14 squared, add them all together and square root it, we will end up with a magnitude of 1, which proves that it's a unit vector. So the second example we've got is we want to find an unknown component given the fact that this is a unit vector. So how do we go about doing that? Well, we know that a unit vector has a magnitude of 1. So we know that this unit vector here, 2/3 I plus dj minus a half k, has a magnitude of 1. So if we then use our 2/3 squared plus d squared plus negative a half squared, that's going to equal 1. Now we want to get rid of that square root sign, so we're going to square both sides, and we're going to do a bit of rearranging. So we're going to put the d squared first, and then we're going to square the 2/3, so that's going to give us 4 over 9. We're going to square negative a half, which is going to give us a quarter, and that's going to equal 1. Now we need to work out what the common denominator is of our fractions. So we've got d squared plus, and we're going to do 9 times 4 is 36, and 4 times 4 is 16, and 1 times 9 is 9, and that equals, and we're going to change this 1 into a fraction out of 36, and so we know that 1 is the same as 36 over 36. So what we end up with is d squared plus 25 over 36 equals 36 over 36. Now, we need to get rid of that 25 over 36. So d squared is going to equal 11 over 36. Now, if we go back up to the top of the question, it said find the values plural of d, and that's a clue to remind us that when we're square rooting, we're going to have a positive and a negative response to our root 11 over 36. Now, this is not in its simplest form because we've got a perfect square on our denominator, so we actually need to square root that. So our final answer is going to be plus or minus the square root of 11 over 6. And we can leave it like that, or we can say therefore d equals root 11 over 6, or negative root 11 over 6. So now let's have a go at some questions, either on Scholar or in the handout. It is unit vectors and zero vectors, and that's the relevant page numbers for you there. Good luck.